So, in yesterday's lesson, we looked at finding exact values on the unit circle. So, ultimately, what we were doing was finding the trig values for, let's say, an angle like pi over 3. So, here is my unit circle just for quadrant 1. And if we think about my triangle that is built for the angle pi over 3, we have our coordinates 1/2 root 3 over 2. So that's the x and that's the y. So in terms of the triangle, the x distance was 1/2 and the y distance was the square root of 3 over 2. And my hypotenuse is really just the radius of the unit circle. And the radius of the unit circle is always 1. So what we're going to look at today is when I have values that aren't on the unit circle. So let's say I have the point that's right here, which gives me this triangle. Here would be my x distance, here would be my y distance. And the issue we run into when it's not on the unit circle is that my hypotenuse is no longer 1. And that's where we're going to run into issues. So we're used to looking at the unit circle and saying for pi over 3 that the sine of pi over 3 is the square root of 3 over 2, right? The y value of the angle measure pi over 3. The reason why we say it's just y is because when you think about SOHCAHTOA back in geometry, sine was so, which is the opposite over the hypotenuse. The opposite to my angle is the square root of 3 over 2, and my hypotenuse was 1. So really I'm doing y divided by 1, which is just y. So when we think about a triangle where r is not 1 anymore, we have my x distance, my y distance, and then my hypotenuse, which we're going to call r. So we have to start by identifying our trig functions in terms of x, y, and r. So sine, or so, thinking back to geometry, is the opposite over the hypotenuse. So here's my angle theta. Opposite over hypotenuse would be y over r. Cosine is adjacent over hypotenuse. So we have x over r. Tangent stays the same. Tangent is opposite over adjacent, so y over x. And then we have our reciprocals. So cosecant is r over y. Secant is r over x. And cotangent is x over y. Now, when we think about our geometry days, when I had right triangles and I needed to find that hypotenuse, in this case find r, I would use the Pythagorean theorem. Okay, and the Pythagorean theorem that you're used to seeing is a squared plus b squared equals c squared. But now we're going to use x, y's, and r's. So the Pythagorean theorem is really going to be x squared plus y squared equals r squared. So first thing we need to identify when we are figuring out things that aren't on the unit circle is I want to start by drawing my triangle. And to do that, I need to figure out what quadrant I'm in. So when I look at this first problem here, I see that I have the ordered pair 3, 4. Okay, so x and y are both positive. That's going to put me in quadrant 1. So let's draw our triangle in quadrant 1. So that's the point 3, 4. So that tells me that the x distance is 3 and the y distance is 4. Now, if you remember your special right triangles, this would be a 3, 4, 5 triangle. But if you don't remember that, we can always rely on the Pythagorean theorem. So we have x squared plus y squared equals r squared. So 9 plus 16, which is r squared equaling 25. Square root, and we get r equaling 5. Now, generally this would be plus or minus 5, and then we'd have to identify the sign, but our hypotenuse, or our R value, is always, always, always positive. So that might be a note you want to make. R is always positive, no matter what. So we have x equaling 3, y equaling 4, and r equaling 5. So using my newly mentioned, I guess, equations for sine, cosine, and tangent, we have sine equaling y over r, so that would be 4 over 5. Cosine would be x over r, so that would be 3/5. And then tangent would be y over x, which would be 4/3. Then the reciprocals, we have r over y, which would be 5 over 4. Secant, which would be r over x, so 5/3. And then cotangent would be x over y. And that's it, right? So let's look at a few more examples. We have -5, -12. So x and y are both negative. So let's first start by figuring out my triangle and what quadrant I'm in. So x and y are both negative in quadrant 3. If you don't remember that, here's a real quick recap here. Quadrant 1, we have positive, positive. Quadrant 2, negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. Okay. So quadrant 3, negative, negative. Start by drawing our triangle here in quadrant 3. So we have an x distance of -5, a y distance of -12. And again, we have a special right triangle here. We have our 5, 12, 13 triangle. But again, if you don't remember that, use the Pythagorean theorem. So -5 squared plus -12 squared equals r squared. So 25 plus 144, which would give me 169, and the square root of that would give me 13. So we have x equaling -5, y equaling -12, and my r value equaling 13. So again, let's just run through the 6 strict functions real quick. X over, or y over r for sine, so -12 over 13. Cosine, -5 over 13. Tangent, y over x, negative over negative would give me positive 12/5. Doing the reciprocals, r over y, so -13/12. And I always put the negative out front, it just makes it easier. Secant would be r over x, so 13 over 5. And then lastly, we have x over y. Again, negative over negative would give me positive 5/12. Moving on, let's look at a problem that is going to be a little bit tougher here. And it's tougher because it's not going to be one of our special right triangles. So again, start by identifying the quadrant in our triangle. So we have -x, positive y. So that is quadrant 2. Draw our triangle here. I have an x distance of -1 and a y distance of 2. So let's find r. So x squared plus y squared equals r squared. So that's going to be 1 plus 4. So I would have r squared equals 5. So r is root 5. So we have x equaling -1, y equaling 2, and r equaling the square root of 5. Now, the crappy part of having a radical for your r is that we're going to have to do a lot of rationalizing. And I don't have a lot of space here, so I'll spell it out for sine, and then the rest of them I'll kind of rationalize it all in one step. So, let's look at sine first. Sine is going to be y over r, so I would have 2 over the square root of 5. Now, to rationalize that, I'm going to multiply top and bottom by square root of 5. So that would give me 2 root 5 on top, and on bottom, I would have the square root of 25. Square root of 25 is 5. So sine of theta rationalized would be 2 root 5 all over 5. Okay? So I'm going to rationalize it a little bit quicker here for cosine. Cosine, I'm going to have x over r. So I would have negative 1 over square root of 5, multiplying top and bottom by root 5 and simplifying everything. That would leave me with negative root 5 all over 5. Tangent and cotangent for this one are easier because there's no radicals involved. So tangent of theta would be y over x, which would be negative 2, right? 2 divided by negative 1. And then the reciprocals aren't that bad either because it puts the radical on the top. So cosecant would be r over y, so root 5 over 2. Secant, r over x, so we would have root 5 divided by negative 1, which would just be negative root 5. And then lastly, x over y, so negative 1/2. Alright, I'm going to do this last one a little bit quicker here, just to get it done. So, positive, negative, that puts me in quadrant 4. Draw our triangle here. So we have a x distance of 4, y distance of negative 6. Again, not one of our special right triangles, so I have to use Pythagorean theorem. So, x squared, 16. Negative 6 squared. So we're going to have r squared equals 52. Now, I see an issue here when I go to square root both sides. I'm going to have r equaling the square root of 52. But the square root of 52 can be simplified. So you always want to start by simplifying any radicals that you can first. So let's look at simplifying the square root of 52. So 52. The perfect square inside of 52 is the number 4. So that would be 4 times 13. So there's my perfect square that I'm going to take out front. The square root of 4 leaves me with 2. So r is really going to equal 2 root 13. So we have x of 4, y of negative 6, and r, that is 2 root 13. Now, this problem is tough because you have to simplify your radical for r. You're going to have to rationalize your denominators. And then on top of that, you're going to have to simplify your fraction after you rationalize. So there's a lot of steps here. So follow along closely. Sine is y over r. So I'm going to try and write as small as I can here. That would be negative 6 all over 2 root 13. Now, I'm going to walk through this kind of slowly here, just for this one here. So, on top, before I even think about rationalizing, let's look at my numbers on the outside. I have negative 6 on top and 2 on the bottom. So that's going to leave me with negative 3 on top. Now, when I go to rationalize, I'm going to multiply top and bottom by just the square root of 13. Okay, so I just want to multiply by root 13. I don't want to do 2 root 13 because that's just going to make me do more work. So, multiplying top and bottom by the square root of 13, that puts the radical on the top, and then plain old 13 on the bottom. Now I just need to check to make sure my numbers still don't simplify. They don't, so that is my answer. Okay. Cosine, x over r. So 4 over 2 root 13. Again, start with your numbers on the outside here. So I have 4 divided by 2. So I would have a 2 on top, and then let's rationalize. So let's put the root on top, and then the plain old 13 on the bottom. Don't overcomplicate it if you don't have to, right? Deal with your numbers on the outside first, and then move your radical up top. Tangent, cotangent again are nice and easy here. Y over x would be negative 6 over 4, but that simplifies and gives me negative 3 halves. Cosecant r over y, so 2 root 13 over negative 6. Simplify all that, so we would have negative root 13 all over 3. Secant r over x, so 2 root 13 all over 4. Simplify, we get root 13 over 2. And lastly, cotangent of theta, we would have negative 4/6, which simplifies negative 2/3. Alright, so that is given an ordered pair, a point. So now let's look at what happens when they don't give us a point. So in this case, it's going to give us some of the trig functions. In this case, it gives us sine and cosine. So we have to unpack all that information, figure out what x, y, and r are, and then use those values to find the remaining trig functions. Okay? So sine of theta equals 2 root 5 over 5. If I think about what sine of theta is, sine theta is y over r. Cosine of theta is x over r. So using that information, I have y over r. So my y is going to be 2 root 5. R is going to be 5. Looking at cosine, cosine's x over r, right? In this case, there's a negative there. Again, r is always going to be positive, so the negative is going to stick with the x. So we have negative root 5 for x, and again, r is 5. So I have negative x and positive y. What quadrant is that going to put me in? That is going to put me in quadrant 2. So there's my triangle. R is 5. I have a y distance of 2 root 5 and an x distance of negative root 5. Now again, you don't have to draw a picture if you don't want to. I always like to draw my triangle though, just so I have everything kind of organized and there's a nice visual to go with it. So I have my x and my y, so let's find tangent. Tangent is a y over x, so we would have 2 root 5 all over root 5. Negative though, right? So put that negative out front. Now I have the square root of 5 on top and bottom, so luckily both of those are going to cancel out, and I'm just going to be left with negative 2. Alright, let's look at the reciprocals now. The reciprocals for this one are a little trickier because I'm going to have that radical in the denominator now. So, cosecant, r over y. So we're going to have 5 over 2 root 5. Again, check your numbers outside first. I have 5 on top and 2 on bottom. Fortunately, neither of those simplify. So we're going to go right into rationalizing. So multiply top and bottom by the square root of 5 only. So on top, I have that 5 from the beginning, right? And then I'm going to have the square root of 5 up there. On the bottom, I'm going to have 2 times the square root of 25. Square root of 25 is 5. So I'm going to be left with 2 times 5 on the bottom, which is going to give me 10. Now, my final step, again, is to check to make sure I can simplify or not. In this case, I can. So this is going to leave me with the square root of 5 all over 2. Secant, we're going to have to do the same thing. Negative 5 over square root of 5. Rationalize. So I would have negative 5 root 5 all over 5. The 5's are going to simplify, and that's going to leave me with negative square root of 5. Last one here. I'm going to have negative square root of 5 over 2 root 5. Radicals cancel, and I'm left with negative 1/2. Alright. Only got a couple more problems here. Trying to erase some of these dots here. Okay. So it gives me sine is negative 2 root 2 over 3. Cosine is negative 1 over 3. So again, we have y and x along with my r. So x is going to be negative 1. Y is going to be negative 2 root 2. And r is going to be 3. So x and y are both negative. That's going to put me in quadrant 3. So here's my triangle. R is 3. X is negative 1. Y is going to be negative 2 root 2. Alright, so tangent y over x. Negative 2 root 2 all over negative 1, which is just going to be positive 2 root 2. Cosecant r over y. Negative 3 over 2 root 2. Multiply top and bottom by the square root of 2. So we have the negative, the 3 is still up there, root 2, all over 2 times the square root of 4. So that's 2 times 2, which leaves me with 4. Check your numbers on the outside. I have 3 on top and 4 on the bottom. Doesn't simplify, so that one is done. Let's look at secant r over x. So we would have negative 3 over 1, which is just negative 3. And then cotangent x over y. Negative over negative, so we can go ahead and get rid of those. It's going to be positive. So I would have 1 over 2 root 2. Rationalizing, I would have the square root of 2 on top, and then 4 on the bottom. Doesn't simplify, so that is my answer. Okay. Alright. Last 2 problems here. So, this time, it's going to give me one exact value, and then some bit of information about theta to help me with the quadrant. So, these are a little bit tougher in that I'm going to have to identify the quadrant, and it's only going to give me 2 of the 3 variables I need, so I'm going to have to use the Pythagorean theorem here. So, in this case, it tells me sine is negative 2 over 3. So that gives me y and r. So I know y is negative 2 and r is 3. Now, I also have this other bit of information here. Okay, it says that theta is in between pi and 3 pi over 2. So if I think about my unit circle, here's pi, here's 3 pi over 2. So that's telling me that my angle theta is in quadrant 3. So my triangle's here. Here's theta. I know I have a y distance of negative 2, and I have an r of 3. How do I find x? Pythagorean theorem. Okay, so I have x squared plus y squared, so negative 2 squared, equals r squared. X squared equals, x squared plus 4 equals 9. Subtract the 4, square root, and I get x equals plus or minus the square root of 5. Now, when it's x or y that we're using the Pythagorean to solve for, we need to include that plus or minus, because I don't know right off the bat, is it going to be a positive x value or a negative x value? And that's where identifying the quadrant I'm in comes into play. So I know I'm quadrant 3 based off the information it gives me. So quadrant 3, that means I'm dealing with negative x values. So x is going to be negative square root of 5. Now I have all the information I need, and I can figure out the other 6 trig functions here. So cosine x over r, negative square root of 5 over 3. Tangent y over x, negative or negative, we can get rid of those 2 things. So we would have 2 over the square root of 5. Rationalize it, so we get 2 root 5 all over 5. Check your outside numbers. I have 2 and 5. Doesn't simplify, so I'm done. Cosecant, r over y. So we have negative 3 over 2. Secant is r over x, negative again. So 3 over root 5. Rationalizing it would leave me with negative 3 root 5 all over 5. Check your outside numbers. I have 3 and 5. Doesn't simplify. Cotangent, we have x over y, negative over negative, so I can get rid of those things right off the bat. So I would be left with the square root of 5 all over 2, and that one's done. So again, the steps there for when you're given one exact value and then some information about theta, unpack the exact value it gives you. Okay, that'll give you 2 of the 3 variables we need. And then use the bit of information it gives you about theta to figure out what quadrant your triangle's in. And then use the Pythagorean theorem to solve for the remaining variable. So, let's start by unpacking. So it gives me cotangent is negative 24 over 7. So cotangent is x over y. Now, the tough part with this is that it's negative. So that means either the x is negative or the y is negative. But I don't know which one is right off the bat just from looking at that. So I do know that the x is 24 and the y is 7. I just don't know the signs of it yet. And that is why I need to look at that second bit of information here. So it tells me sine of theta is less than 0. What that's telling me is that my y value has to be negative, okay, for it to be less than 0. So y is negative. That means I have x as a positive number and y as a negative number. So that, again, is going to put me in quadrant 4. Okay, negative y, positive x. So I know that x is 24. I know that y is negative 7. And if you don't know this, this is a special right triangle. It's one of the bigger ones, though, so this one most people don't remember. But we have 7, 24, and 25, which would be our hypotenuse. But again, if you don't remember that, it's okay. Use your Pythagorean theorem. So 24 squared is negative 7 squared equals r squared. 24 squared. So I know this is 49. Bear with me here. $576. Sorry, I don't have a calculator sitting next to me. Add those up, and we should get 625. So we have r squared equals 625. The square root leaves me with 25. And again, I don't need the plus or minus because r is always positive. Again, this is quadrant 4. Alright, so luckily I don't have any radicals to deal with here. So these are nice and easy. Sine, y over r. So negative 7/25 doesn't simplify. So move on to cosine, x over r. 24/25 doesn't simplify. Tangent, we have y over x. So negative 7/24. Again, doesn't simplify. Cotangent's already done for me. So let's go up here to cosecant. We're just going to flip around. So we have negative 25/7, and then we have 25/24. And again, that doesn't simplify, so we are done.